In this session, we will uncover the next string class, which is string builder. It is same like string buffer, which was introduced in Java 1.5 version. It is a mutable object, and all constructors and methods present in string buffer are available in string builder also. And if the content is not fixed, keeps changing, use string builder. So if it is similar to string builder, string buffer, so what is the difference? So difference is string buffer is synchronized. Only one thread is allowed. If only one thread is allowed, you can use string buffer. And if multiple threads are allowed, you can use string builder. String builder is not synchronized. Multiple threads are allowed. Everything else is same. So let's move on to the next class, which is string tokenizer. It is process of dividing a string into tokens based on some delimiter. We are dividing string into tokens. Let's see some examples. Say, for example, I have a string called Java is very easy. And if I have to tokenize, it's going to return Java, is, very, easy. So here, default delimiter is space. For example, if I have A, B, C, comma, D, E, F, comma, E, F, J, comma I A L comma P Q R comma W X Y Z. And if we have to tokenize based on comma, then we will get these tokens. Stat space is here. So these are individual tokens. Let's say if I have some date like this, and then if I have to tokenize this based on hyphen, then it's going to give me 12 comma 31 comma 2030. So if I have time something like 0 0 0 0 0 0, or maybe for the benefit of clarity, I'll just add like this, then what I'll get 0 0 comma 0 1 comma 45. This is how string tokenizer with a delimiter works. Let's look at some constructors under string tokenizer. The first constructor is string tokenizer st is equal to new string tokenizer of string. So it will tokenize based on the default tokenizer, which is space. We have another option to give the tokenizer, that is delimiter. So it will tokenize based on given delimiter. Let's move on to some methods available in tokenizer. First one is int count tokens. So it will count number of tokens. And let's move on. Another method called Boolean has more tokens. What it does, returns true if next token is available, else false. Another method, string next token. Return current token and transfer next token. We'll see some examples around these methods. So the first one is say, for example, if I have a string s is equal to Java is very easy to understand and practice. This is my string. So if I take a string tokenizer, st is equal to new string tokenizer and specify s. And if I count tokens, we get the number of tokens available. If we do not specify delimiter, it's going to be space. So 1, 2, 3, 4, 5, 6, 7, 8. So we should get 8 tokens. Compile, execute. Now let's look at has more tokens sample. What I'll do, I'll use a while loop and say sd dot has more tokens. This is true. Then I'll print the next token. Next. So it will print all the tokens one by one. Let's look at that example. Compile, execute. It's going to print the tokens one by one. So for example, if I do tokenize based on, say, E, which means that it will tokenize until here, then until here, and then until here. So now let's try to count the tokens. It's gonna count. Let's see how many we get. Compile, execute. So it's gonna take until E, first E, second E, third E, fourth E. So 4 tokens, that's the count of tokens. It's the result here. So for example, let's say I need to develop an application which convert each word to each word in the string to uppercase. If length is greater than 4, this is our requirements. So how do we achieve this? Let's see in the example. So I have string tokenizer. I'll use just space as delimiter, and then I'll use a new string buffer and save the result in this new string buffer. So what I'll do, while has more tokens, I'll take string, say temp, and assign the next token here. And if temp of length is greater than 4, what I'll do, I'll use result dot to uppercase. Else, I'll use result dot temp as is. And finally, I'll add space in between the tokens, and I'll print the original string S, and then I'll print the result. So let's try to compile and run this program. Compile. I should remove this. Compile. Execute. So if you see the string which is more than 4 characters is in uppercase and everything else is in lowercase. That's how we can achieve this requirement. We put the results in the notes. This completes our string classes. Now let's look at regular expressions. So what is a regular expression? A regular expression is an expression which represents a group of strings according to some particular pattern. So what does that mean? Let's see some examples. We can pair a regular expression to represent, say, credit card PIN number. So usually credit card PIN will be from 0 to 9. So this is a regular expression. Anything else cannot be a credit card PIN number. Similarly, we can prepare a regular expression to represent, say, mobile number. We can prepare regular expressions to represent names as well, etc. so on and so forth. So what are the steps to prepare regular expressions? The first step is to import java.util.regular expressions package. The second step is create an object for pattern class, provide a format. Number 3, create match object to get matched string. Let's look at one example to get more clarity on this. For example, I will import util.regex package and say my string is something like A1 B space M9 C space H8 I4 uppercase J 6 K3 special symbol W, maybe @ uppercase X and Y star. Now I need to declare a pattern. P is equal to pattern dot compile and I need to look for say 0 to 9. Now I need to matcher M is equal to P dot matcher S. So I'll use a while loop and say M dot find and I'll print M dot loop. Let's compile and run this. So I'll get all the numbers which are present in my string from 0 to 9. So these are the available numbers in the current string. So that's how I get the regular expression 0 to 9. Say, for example, if I just need uppercase A to uppercase Z. Let me compile and execute. I have uppercase J, uppercase X, and uppercase Z. So that's my result. Say, for example, I need 0 to 9 and uppercase A to Z. Let's see how the result will look like. Compile, execute. So if you see here, this is the only occurrence where you will see 0 to 9, which is 4, and uppercase Z. So here there is an uppercase X, but it is not having a number in front of it. And we have an uppercase Z, but it doesn't have a number in front of it. So this is the only pattern that is available. So that's how you can get another kind of pattern if you define that way. Now, let me change this to lowercase a to lowercase z. Let's see how many such patterns or regular expressions are available. Compile, execute. So I have 1b, 9c, 8i, then 6k, then yeah, that's all I have. Get the result here. So we have some predefined character classes. Let's see what are those. If you use lowercase s, then you get spaces. If you use uppercase yes, s, you will get except spaces. So let's see how this works. Uppercase s, compile. Execute. You'll get all the characters without spaces. I'll not paste the result, it's too long. If you use lowercase d, you will get all the digits. If I change this to lowercase d and execute, you'll get all the digits available in that string. And if I do uppercase d, you will get everything except digits. If I use lowercase w, word characters like A to Z, comma, uppercase A to uppercase Z, comma, 0 to 9. If I use dot, you will get all characters. So if you do lowercase d, then you'll get all digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If I don't want some digits, say for example, I need until 5, then I can use a regular expression like 0 to 5. That will only give 0, comma 1, comma 2, comma 3, comma 4, comma 5. this is how you can define a regular expression. So you can use user defined regular expressions as well. So say for example, you can use a comma b comma c. What it does, it will get you either a or b or c. Say for example, if I use cap, then I'll get except a, b, c, everything else. And say for example, if I use 0 to 9, I'll get all digits from 0 to 9. And if I do cap 0 to 9, I'll get except digits from 0 to 9. And if I do a to z, lowercase a to z, then I'll get all lowercase characters. And if I do uppercase a to z, then I'll get all uppercase characters. Similarly, if I do cap of a lowercase a to z, I'll get except lowercase characters. If I do cap of uppercase a to z, then I'll get except uppercase characters. I can also do a to z and uppercase a to z. Then I'll get all lowercase and uppercase. And if I do not a to z, then I'll get except lowercase and uppercase. I can also do a to z, uppercase a to z, 0 to 9. Then I'll get lowercase, uppercase, and all digits. So you can define any number of user-defined regular expressions based on your requirements. Let's move on to something called quantifiers. What are these? Let's see some example. If I have a string S and say I have 1AB, then 2AB, then 3AB, then 4AB, then 5AB, then 6AB. And then my pattern match is for A, then try to print the match pattern. So let's compile and execute. So I have all the A's here. I can also do A plus, so it will print all the patterns that are there instead of single A's. So let's compile and see the result, how it looks. So it will get all the patterns which have at least A and those many A's that are present. And I can also set the size, for example, A of 3. If there are 3 or more A's, just print those regular expressions. So let's compile and execute. I have 1, 2, 3, 4, and 5. So let me summarize. If I use just A, then exactly 1A is printed. If I use A plus, then 1 or more number of A's. If I print A of M, then I'll get exactly M number of A's. With this, we finished strings of Java.